Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fazal bin Masali. I'm from CS24548. Clock in for ITT440 at 9:58 a.m. on 4th January 2021. I'm number 5 on the list. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad Hafizul Haq bin Fadilah, number 1 on the list. Clock in for ITT440 at 0959 hours on 4th January 2021.
My name is Muhammad Osman, number 9, clocking in for ITT440 at 10 a.m. on 4th of January 2021.
Assalamualaikum, my name is Fatina Ayuni binti Muhammad Jani, number 2, clock in for ITT440, 10:01 a.m. 4 January 2021.
Clock in at 10:01 a.m. on 4 January for the class ITT440. My name is Siti Nursyafawati binti Mahashim and my number is 15.
Assalamualaikum warahmatullahi wabarakatuh. My name is Fatima binti Jafar, number 12, clocking in for ITT440 at 10:03 a.m. on 4 January 2021.
My name is Nur Sabrina binti Zainal, clock in for ITT440 10:04 a.m.
Assalamualaikum, my name is Muhammad Iman bin Zainuddin, number 8, clock in for ITT440 at 10:04 a.m. on 4 January 2021.
Assalamualaikum, my name is Muhammad Adhanif. I will clock in for ITT440 at 10:05 a.m. at 4 January 2021. Thank you. By the way, I'm number 4 on the list.
My name is Muhammad Afiq bin Azhar, number 3 on the list. Log in for class ITT440 at 10:05 a.m. 4 January 2021.
Assalamualaikum. My name is Muhammad Firdaus bin Ishaq. I'm number 16 in the list name. I'm here to clock in for class ITT440 at 10:06 a.m. on 5 January 2021.
Okay, my name is Muhammad Anwar bin Johari, number 7, clock in for ITT440 at 10:07 a.m. on 4 December 2020.
My name is Muhammad Nasir Maim Aziz. I'm number 6, calling for ITT440 at 10:08 a.m. on 4 January 2021. Muhammad Naufal bin Muhammad Aris, log in for ITT440 on 4 January 2021 at 10:11 a.m. Thank you.
Assalamualaikum, my name is Nur Zazwani, number 40, clock in ITT440 at 10:22 a.m. For January 2021.
My name is Muhammad Kazim, number 10 on the list, clock in for ITT440 on 10 January 2021 on 10:08 a.m.
Assalamualaikum.
Waalaikumsalam, sir.
Dengar.
Dengar, sir, dengar.
Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. Wassalatu wassalamu ala asyrafil sayyidina wal mursalin wa ala alihi wa sahbihi ajma'in. Subhanaka la ilma lana illa ma 'allamtana innaka antal alimul hakim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Wala hawla wala quwwata illa billahil 'aliyyil 'azim. Allahumma shalli ala sayyidina Muhammad wa ala alihi wasallam. So alhamdulillah, ini kita masuk chapter last, final chapter. Okay, parallel programming in Python. So minggu lepas kita dah try buat coding kan. Macam mana Rizak? Boleh faham tak dia punya konsep dah?
Boleh, sir. Faham.
Okay. So, ini kita tengok slide lah. Alright. Okay. Sekejap lah. Tak jumpa dia punya ni. Nampak dah. Tak ada respon pun.
Apa sah?
Sunyi je macam saya cakap seorang-seorang.
Oh. Ya.
Ada ke?
Tak ada suara.
Tak ada suara.
Sekejap sekali lagi.
Ada apa? Apa yang tak ada suara?
Tadi saya cakap tak ada suara. Sekarang baru keluar suara sir.
Betul senyap. Ke saya terputus. Network tadi dah putus dah sekali. Masuk-masuk tadi dah putus dah sekali. Okay, sekali lagi. Alright, so our content today, dengar kan? Kali ni dengar kan?
Dengar sir.
Dengar.
Content outline today is thread. First is thread versus processes. Okay, and then second parallel versus concurrent, and last is Python parallel programming ecosystem. Right. By the end of the lesson, students should be able to understand the basic concept of CPU hyperthreading, and students should be able to write parallel programming in Python. Okay, clear kan? First kita masuk thread. Tak jalan. Jalan. 2 kali tekan. Mouse saya yang problem lah. Thread versus process. So rasa-rasanya apa beza dia thread? Ada beza tak thread dengan proses? Proses kita dah belajar daripada awal SEM. Final SEM kita awal SEM kan? Awal SEM kita belajar proses, and then kita tutup dengan thread. So, boleh beza tak thread dengan proses?
Base ada dia macam mana cakap, dia konsep sama tapi
persamaan dia ada kan?
Persamaan dia ada.
Dia tengah dia run the job kan? Dia akan hantar ke CPU kan. Okay. So sebenarnya kita boleh cakap macam inilah, dia bukan perbezaan lah. Sebenarnya thread ni adalah sub kepada proses. Kalau tanya saya lah, dari segi pemahaman saya, so thread ni adalah sub of proses lah. Kan, dalam proses tu dia ada kecil-kecil dia lagi, dipanggil thread. Itulah. Kan. Tidak apa. Okay, so gambar kat sini Intel punya logo. Okay, Intel Pentium. Kat situ, kat mana thread dia? Perkataan HT tu, lepas tak?
Hyperthreading sir.
Hyperthreading. Okay. So dia perkenalkan hyperthreading lah. So what is hyperthreading? So hyperthreading was Intel's first attempt okay, to bring parallel computation to consumer PCs. Okay, it debuted on desktop CPU with the Pentium 4 HT back in 2002. The Pentium 4s of the day featured just a single CPU core. Okay, sebelum tu dia ada CPU, ada single CPU kan, so it could really only perform one task at a time. Even if it was able to switch between tasks quickly enough that it seemed like multitasking, hyperthreading attempted to make up for that. So a single physical CPU core with hyperthreading appears as two logical CPUs to an operating system. Okay, the CPU is still a single CPU, so it is a little bit of cheat lah. While the operating system sees two CPU for each core, the actual CPU hardware only has a single set of execution resources for each core. The CPU pretends it has more cores than it does, and it uses its own logic to speed up program execution. In other words, the operating system is tricked into seeing two CPU for each actual CPU core. Hyperthreading allows the two logical CPU core, okay, so allow the two logical CPU cores to share physical execution resources. This can speed things up somewhat if one virtual CPU is tall and waiting. The other virtual CPU can borrow its execution resources. So HT can help speed your system up, but it's nowhere near as good as having actual traditional additional core. So thankfully, hyperthreading is now a bonus. While the original consumer processor with HT only had a single core that masqueraded as multiple core modern Intel CPU. So now we have both multiple core and hyper-threading technology. Betul tak? So your dual core CPU with hyper-threading appear as 4 core to your operating system. So nampak dual core tapi dia nampak 4 core kan? Nampak dia double up lah kan? Dah lah dulu kita nak buat core kan? Multi-core. Tapi sebelum tu kita buat multi threading tu hyper thread HT dulu kan. Kita nampak macam ada dua. Kemudian kita ada multi core, kita ada dual core. So HT so akan nampak macam quad core kan. Okay. So why your quad core CPU with hyper threading appear as 8 core. Hyper threading is no substitute for additional core, but a dual core CPU with hyperthreading should perform better than a dual core CPU without HT. Macam itulah. Dia memang nampak macam tak sama, dia tak sama, betul-betul tak sama dengan physical 4 core. Kan? Kita ada dual core and then HT, so kita nampak macam quad core, tapi dia tak betul-betul really quad core, tapi dia better than dual core yang tak ada HT. Understand tu?
Sir, slide saya gerak ke sir?
Tak gerak.
Oh, memang biasanya.
Okay.
Oh.
So multi-core originally CPU had a single core. That means the physical CPU had a single central processing unit on it to increase performance. Manufacturers add additional core or central processing units. A dual core CPU has two central processing units, so it appears to the operating system as two CPU. A CPU with two cores, for example, could run two different processes at the same time. So this is speed up your system because your computer can do multiple things at once. So unlike HT, there are no tricks. So a dual core CPU literally has two central processing unit on the CPU chip. Okay. This help dramatically improve performance while keeping the physical CPU unit small, so it fits in a single socket. So socket tahu kan? Tempat nak letak CPU, there only needs to be a single CPU socket with a single CPU unit inserted it. So not 4 different CPU socket with 4 different CPU is needing their own power, cooling and other hardware. So there's less latency because the core can communicate some quickly as they all on the same chip. Okay, macam mana kita nak tengok multiple core ni dekat komputer?
Task manager, sir.
Yes, Windows Task Manager show this very well lah. So kalau kata dia nampak satu, kita boleh ambil advance kat situ kan, ada option dia. Alright. So a dual CPU literally has 2 central processing unit on the CPU chip. So a quad-core CPU has 4 central processing unit and octa-core 8 has octa-core 8 has 8 central processing units. Okay. Kalau 16 apa 16? Hexadecimal lah.
Hexacore.
Hexa 6.
Entah.
Hexa 6.
Hex 6.
Decimal 10 kan. Hexadec kan. Tapi nak sebut dia tak tahu lah. Okay, so ini yang kita dapat simpulkan core versus hyperthread. In hyperthreading, the operating system is strict into seeing 2 CPU for each actual CPU core. They are not strict on multi-core. A dual CPU literally has 2 central processing unit on CPU chip. So a quad-core CPU has 4 central processing units and a core has 8 central units and so on. So modern CPU now have both multiple cores and HT technology. So dual core CPU with HT appear as 4 core to your OS. Okay, hyperthreading is no substitute for additional core. Cerita sekali lagi, but a dual core CPU with hyperthreading should perform better than a dual core CPU without hyperthreading. So how threads work? Okay, a thread is the unit of execution within a process. Nampak tu? Ini saya kata sub tadi kan. Saya simpulkan dia sebagai sub process lah kan. A process can have anywhere from just one thread to many threads. So when a process starts, it assigns memory and resources. Each thread in the process shares the memory and resources in a single thread process. The process contains one thread. So the process and the thread are one and the same, and there is only one thing happening. Okay, so programs are typically stored on this or in non-volatile memory in a form that can be executed by your computer. So the program has been loaded into the computer memory in a binary form. Okay, yang ni banyak kali diulang dah, termasuk dalam Cisco pun sama kan, macam mana dia bergerak, OS bergerak kan. And then an executing program needs more than just a binary code that tell the computer what to do. The program needs memory and various operating system resources in order to run. So a process is what we call a program. So program, kadang kita panggil program, kadang kita panggil proses. So dia akan loaded into memory along with all resources it needs to operate. So apa yang saya dapat simpulkan? Okay, so kita buat sikit table. So thread is lighter weight operation. So process is heavyweight. Kalau nak bandingkan lah, kalau nak bandingkan harga dengan thread dengan proses. Okay, so thread has its own memory space. So process use the memory to process the process they belong to. So in thread IPC is slow. Kita kan pakai IPC dekat proses. So IPC akan inter-thread communication can be faster than IPC. Context switching, okay, between process is more expensive. Context switching between thread are the same. Process is less expensive. So process don't share. Saya rasa salah ni. Terbalik thread dengan proses. Terbalik ni. Yang ni terbalik. Oh, perasan. Sepatutnya sebab ini thread di sini, proses ini. Jadi ajaran sesat lah. Boleh ya? Kau betul kan? Semula. Okay. So silap kat situ. So sini adalah proses. Proses is lighter weight operation. So thread is heavy weight. So thread ni lagi banyak lah kan. Satu proses ada banyak thread. So proses ada memory. Betul tak? Proses ada memory kan. Dia program kan. And then thread use the memory process. Okay. So dia akan pakai yang ini. Thread akan pakai yang ini. So dalam proses IPC is slow. Kalau nak tengok laju, mana laju, IPC slow berbanding dengan inter thread. Mana ni? Nah sini. Okay. So the cut process context switching between process is more expensive, and then thread context switching between thread of the same process is less expensive. Okay. So process don't share memory with other processes, and then thread share memory with other thread of the same process. Kena betulkan ni. Sebab tajuk dia kot kan. Proses sini, thread sini. Okay, next kita pergi to second subtopic, parallel versus concurrent. Apa pula tu? So, whether process or threads can run at the same time. Saya hidup lagi ke kat internet ni?
Hidup sir.
Ada sir.
Okay, saya takut
Ada.
ada orang lagi. Okay. So, adakah proses or thread can run at the same time? Boleh tak? The answer is it depends. Ada sini jawapan dia. So on a system, kan? On a system with multiple processor or CPU core, multiple processor, process of thread can be executed in parallel. Okay. Faham ni? So kita dah masuk ke concurrency dengan parallelism. Parallelism ni apa lah? Tahu? Parallelism.
Dia gerak sekali sir. Macam ada banyak
apa
world.
Oh, dia macam world. So a question you might ask is whether process or thread can run at the same time. So the answer is it depends. So on a system with multiple processor or CPU core, so multiple as is common with modern processors. CPU core kan, multiple process or thread can be executed in parallel. Okay. On a single processor, it is possible to have process or thread truly executed at the same time. In this case, the CPU is shared among running process or thread using process scheduling algorithm that divides the CPU time and yield the illusion of parallel execution. The time given to each task is called a time slice. Okay. The switching back and forth between tasks happen so fast it is usually not perceptible. So kita tak perasan pun, kecuali kita hold dia. Selalu kita akan letak sleep lah dalam coding, kita akan letak sleep supaya ada nampak lah sikit kan. So the term parallelism, okay, genuine simultaneous execution and concurrency adalah interleaving of process in time to give the appearance of simultaneous execution. So distinguish between the two types of real or approximate simultaneous operation sebenarnya. Okay, so kita tengok dia punya illustration. Okay, macam mana CPU dengan concurrency dengan parallelism. Okay, concurrency means that an application is making progress on more than one task, so at the same time or at least simply at the same time, ataupun kita panggil dia sebagai concurrently lah. Concurrently. If the computer only has one CPU, the application may not make progress on more than tasks exactly. Your internet connection is unstable, dia cakap kat saya. Kamu ada tak? Dengar tak? Dah hilang. Siapa ni teruk sangat lah internet. Hilang okey je. So if the computer only has one CPU, the application may not make progress on more than one task at exactly the same time, but more than one task is in progress at a time inside the application. So to make progress on more than one task concurrently, the CPU switches between the different tasks during execution. Okay, so kat sini nampak dia punya concurrency. So dia akan dia ada dua task di situ. Kan? Nampak tak? Oh lama dah hilang dah.
Nampak.
Saya ingatkan dah hilang internet. Ni yang pertama. Dia nak selang-seli dengan task 1, task 2 nampak? Okay, task 2 dia nak start. Nampak dia kena tunggu habis. Dekat task 1 punya ni. Boleh?
Boleh Ustaz. Sir, off mic sir. Setengah mute.
Okay, and then the second task dia nak selang kan. Okay, second task dia buat selepas habis task 1 ni. And then nak sambung buat task 1 balik kan. Nampak dia kena tunggu timeline ni kan. Okay, ini buat dulu, lepas tu 2, lepas tu 1 balik, tu 2 balik. So dia bukan parallel lah. Dia kena tunggu kawan ni habis job baru boleh buat. Okay, so beza dengan parallel execution. So parallel execution is when a computer has more than one CPU or CPU core and makes progress on more than one task simultaneously. However, parallel execution is not referring to the same phenomenon as parallelism. Dah nampak? Dengar. Dah hilang dah. Okay, nampak dia jalan serentak, dia tak boleh tunggu selang-seli. Saya mute ke ni? Pening dah ni. Ni tak kan?
Dengar saya.
Okay. So dia tak perlu tunggu macam tadi, dia boleh jalan serentak kan? Okay. And then kita ada parallel concurrent execution. It is possible to have parallel concurrent execution where threads are distributed among multiple CPU. Thus, the thread executed on the same CPU are executed concurrently, whereas thread executed on different CPU are executed in parallel. Boleh ada both. Macam ni. Nampak ada concurrent. Ada concurrent tapi dekat second CPU kita boleh run task yang lain selain daripada task 1, task 2. Nampak? Task 3, task 4. Dipanggil parallel concurrent execution. Term dia semakin tambah. Parallelism, okay, betul seperti kamu kata, the term parallelism means that an application split its tasks up into smaller subtasks which can be executed processed in parallel, for instance on multiple CPU at the exact same time. So parallelism ni macam world dia lah, kan, dunia dia macam mana kita kena imagine sebenarnya, kan, ada ism ni. Those parallelism does not refer to the same execution model as parallel concurrent execution. So even if they may look similar to the surface, so to achieve true parallelism, your application must have more than one thread running. So and each thread must run on separate CPU ataupun CPU core ataupun graphic card ada GPU core kan. Kan ada mati juga situ kan, mati core. Oh, whatever lah yang ada.
Ada sir. Kuda kos sir.
So the diagram here illustrate bigger task, okay, which is being split up into 4 subtasks. Okay, there is 4 subtasks are being executed by 4 different thread. Ada 4 thread which run on 2 different CPU yang tadi. This means that part of these subtasks are executed concurrently, those executed on the same CPU, and parts are executed in parallel. Okay, those executed on different CPU. Okay. Okay, if instead by 4 subtasks were executed by 4 thread running on each their own CPU, so semua sekali ada 4 CPU, then the task executions would have been fully parallel. Okay. However, it is not always easy to break a task into exactly as many subtasks as the number of CPU available. Often, it is easier to break a task into a number of subtasks which fit naturally with the task at hand, and then let the thread scheduler take care of distributing the thread among the available CPUs. So combination tu, kita ada concurrency and parallel combination, concurrent not parallel, parallel not concurrent, neither concurrent nor parallel, dua-dua tak ada. And then yang tadi kita panggil dia concurrent and parallel. Boleh? So kita boleh simplikan ada 4 jenis. Yang tak ada langsung, neither concurrent nor parallel. Ada concurrent saja. Okey, ada parallel saja dan ada dua-dua. So ada 4 lah. Clear? Sebelum kita masuk Python.
Faham sir. Faham.
Alright, good. Habis dah, so kita pergi the last topic of the syllabus. Last topic of syllabus terus kan. Okay, bukan setakat chapter ni saja. The whole chapter 1 sampai 9 ni adalah last topic, the Python parallel programming ecosystem. Okay. Okay, kalau tengok gambar ni logo Python, dia pakai font apa ni? Pernah jumpa tak font dia dekat Google font?
Tak sir, saya
tak pernah kan?
Tak tahu sir.
Okay, and then logo dia gambar apa?
Tak.
Gambar ular. Python
Gambar ular.
ular sawah ni, ular sawah. Kan? Okay, ular sawah. Dia ada satu lagi, ada anaconda. Semalam saya store anaconda. Kan? Okay. So apa beza ular sawah dengan anaconda?
Satu lagi dia kuat sir.
Ular sawah dia cantik sikit dah sebab dia batik kan. Kan? Dia ada batik kan. Anaconda tak ada kan. Tapi saya pernah tengok anaconda dekat, bukan dekat museum, dekat zoo ataupun dekat taman ular antara dua tu. Dia boleh naik, berdiri, dia boleh memanjat dinding. anaconda dia boleh panjat dinding, menegak naik ke atas tu. Yang
Macam mana Ustaz?
dia
Pakai dia punya kulit ke?
macam mana dia buat tak tahu, Allah Alam kan. Tapi yang saya tengok kalau dia orang tangkap ular, dia orang pegang ekor ular tu takkan boleh apa? Takkan boleh melantun ke ekor dia kan. Dia tak boleh nak patah balik kan. Itu kelemahan ular. Okay. Tu recording ni. The maximum number of process can be run. The maximum number of process can be run at the time is limited by number of processor in your computer. Okay, so sebenarnya dia depend on processor lah. If you don't know how many processor are present in the machine, the CPU can't function in multiprocessing will show it. Nak ambil ni mana coding ni? Saya nak ambil kopi, rupanya saya pun kena tipu. Ini adalah image, bukannya apa nama? Bukan saya type dekat PowerPoint pun. Okey, mana kita punya kita punya Jupiter. Alah. Okey. Nampak skrin? Boleh besarkan tak? Boleh. So kita try.
Nampak Ustaz.
Import multiprocessing SMP. So kita print saja number of processes. Okay. So kita pakai mp.cpu_count. Dah. Oh ni number of processor kan. So dia yang ni menunjukkan bukan menunjukkan maximum number of processor, ni menunjukkan number maximum of, ini menunjukkan number of processor je. So ada
ni
coding
prosesor kita lah.
Processor saya lah ni, number of processor. So, kamu boleh try dekat kamu punya ni lah, coding dia kan. Tak jadi je nampak. Markdown kan. Okay. Processor number. Next. So kat sini ada synchronous execution. So kalau ada synchronous, kita akan ada asynchronous execution. So asynchronous bukan async lah. Synchronous execution is when the process are completed in the same order in which it was started. So this is achieved by locking the main program until the respective process are finished. So while asynchronous execution. So asynchronous execution, on the other hand, doesn't involve locking. As a result, the order of result can get mixed up, but usually gets done quicker. So how to create a process which print the assigned ID? So by subclassing multiprocessing.process. So you can create the process by run independently. So by extending the init method, you can initialize resource and implementing process.run method. So you can write the code for subprocess. Ini the first create process which print that which print the assigned ID. So kita nak create a process. So create a process. So jadi enter je, saya pergi tekan shift enter. Lepas 3. Okay, prints the assigned ID. ID markdown, sorry. So tadi import multi-processing, import time, pergi. Kita create class, nama dia proses. So kat sini kita pakai multi-processing.process. Okay, buka tutup. Untuk pakai ni dia dah indent kat kamu siap kan? Okay, ini okay, save ID. Buka tutup ni. Okay, super process save. Okay, this process tak ini saja ini. Okay, so ID sama dengan ID. So kita run, tutup. Time.sleep. Awak dah pakai sleep kan? So print and the process with ID. Dot ke koma? Koma kan? Run dulu. Bukan masalah sini. Masalah di sini. Tak ada. Tak keluar. Dalamnya. Tak keluarkan ni. Dapat ah? Nanti kamu try siapa dapat ni bagi tunjuk screenshot boleh?
Ni yang dalam slide tu ke?
Dah slide dah. Tak jumpa, tak dapat. Okay, ni dia punya dia punya explanation ya. Okay, so kita nak pakai print the assigned ID. Boleh kan ni? To spawn the process, we need to initialize our process object and invoke process start method here. Process start. We create a new process and we'll invoke the process.run method. So the code after p.start will be executed immediately before the task completion of process p. So to wait the task completion, you can use process.join. So akan ada dot run dengan dot start dengan dot run. Yang tadi kita ada dot mana ada dot run, tak ada kan? So yang ni next yang kita pakai yang ni. Ada dot start dengan dot join. Run pakai dekat startan. Ini continue yang tadi. Macam mana nak continue yang tadi pun tak dapat? Import multiprocessing, import time, class process, multiprocessing, dot process to
Saya try sekali.
self ID, super process, self init, self ID sama ID, to def run, self, time dot sleep, print. Ini tadi. Okay, so kita kat sini kita start. Kita sama dengan proses p dot start. Okay, kita nak tunggu p dot join. Lepas p dot process 1 pula, second one. So kita kena macam tu kat p dot start and then p dot join. Okay, bismillahirrahmanirrahim. Nah, error. Oh. Keluar pun. Cuba try dekat ni, saya pakai dekat ni, apa nama, Jupyter. Tak jadi. So kamu try dekat IDE yang lain kan? Pacam ke? Tapi dalam video saya lepas tu jadi kan? Tak apa, kita tengok slide, kita habiskan slide dulu, nanti kita try hands on sekali lagi. Okay. Kita tekan meet dan hands on lagi sekali. Okay, selain daripada print ID, kita boleh guna pool class. So pool class can be used for parallel execution of a function for different input data. So multiprocessing.pool. Kat sini kita pakai multiprocessing.pool. So this is a class spawns a set of process called worker and can submit tasks using methods apply, so ataupun apply async ataupun pakai map sync. So parallel mapping, you should first initialize a multiprocessing.pool object. The first argument is the number of worker. If not given, that number will be equal to the number of core in the system. So kalau kita pakai yang pool class ni, so declare dia macam ni, and then initialize kan. Okay, ni contoh coding. Kamu try nanti capture screen lah kan, tak dapat kaedah yang kedua ni. Jadi kaedah yang pertama kan ada start dengan join. Ini kita boleh pakai pool map kan. Okay, and then kita cepatkan concurrent network server. So server type application that communicate with many clients simultaneously demand both a high degree of concurrency and high performance from the I/O subsystem. A good web server should be able to handle hundreds of thousands of concurrent connection and service tens of thousands of requests per second. So kita dah belajar concurrent, ada threading. So concurrent ni ada kegunaan dia lah. Okay, dalam network server. So ideally we would like to write this kind of application using thread. So a thread, the write application, nama saja concurrent tapi kita write application using thread kan. So it allow the developer to focus on programming the interaction with a single client and then to leave with interaction to multiple client by simply forking many instances of the single client interaction in separate thread. So kita pakai dalam contohnya clustering kan. Okay, so kita ada multiple server kat situ. So dia nampak macam parallel lah kan. Kita boleh tak perlu tunggu dia request seorang-seorang habis, so sebenarnya dia boleh layan semua klien sebab dia ada parallel kat situ. Parallelism kan, walaupun nama dia concurrent tapi program yang kita pakai tu kita tulis dalam thread. So conclusion to final chapter ni, there are various ways to implement parallel processing using the general procedure and multitasking module. So taking advantage of this benefit is indeed the same for any size machine. So the result will get speed depending on the number of processor when the procedures are followed exactly. This is a beginning of knowledge of programming which we started by using Python language. So in network programming, this parallelism can be accomplished by concurrent network server. So beza kat situ, kita dah tahu beza parallel dengan concurrent, tapi dalam banyak-banyak tu ada 4 benda tadi kan. Ada yang dua-dua jalan serentak kan. Okay, that's all. Any question? So don't forget to refer this. Kan kat sini ada banyak lagi information, ataupun kamu boleh dapatkan Google ataupun daripada YouTube lah. Kan ada banyak lagi explanation. Alright. Okay, stop sharing.
Sir,
Ya.
tadi saya try.
Hidup? Jalan tak?
Tak, sir.
Tak
Kosong.
juga?
Tapi yang kedua ni saya ada error sebab
tak apa, kamu cari yang lain, example yang banyak kan.
oh, okay. Tahu. Saya
kalau tak yang GitHub yang
okay,
saya
sir, tak ada.
kan.
Oh, ada, sir. I in the process with ID kosong, I in the process with ID 1.
Oh, ada lah. So dekat Jupiter
Ni
je
yang kedua
nampak.
jalan saya.
Dekat Jupiter tak
Dia
nampak.
keluar.
Pacam ke direct ke?
Ni saya pakai kat Ubuntu Python 3.
Oh, Python siap lah tu. Okay.
Ha.
Alright, so that's all for today. Thank you for your time. So don't forget to clock out. Assalamualaikum.
Waalaikumsalam. Terima kasih sir.
Okay.
Thank you, sir.
Kita tutup dengan tasbih kifarah dan suratul Quran. Subhanakallahumma wa bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Bismillahirrahmanirrahim. Assalamualaikum.